we invite thought leaders and innovators to discuss their approach of the future. Today, I have a very special guest, Sumit Jamuar, chairman of Global Gene Corporation. He holds undergrad from IIT Delhi. He's on the board of several organizations. He's an engineer. He's a financial guru. Now he is he's working on solving health for all problem. Let's talk to him and understand what is his vision. So Sumit, welcome to our show.
Thank you, Sanjiv. Thank you for having me here.
So Sumit, you believe that we are all born with a signature, which is very unique. Your mission is to decode that signature so we can live better. What that really means to a common person like me.
Sanjiv, it's a very exciting topic, and it's something that when we trained as engineers. We trained for looking at frontier technologies and looking at what it means in terms of applying for benefit at a large scale for humanity. And one of the things which fascinates me in the work is, as you mentioned, I'm the co-founder of Global Gene Corp. And what we're looking at is we are saying the signature, as you call it, is the DNA. And what we believe is that DNA is the code for each one of us. And if we understand it, and if we interpret it, and if we can make use of it, we can all have a highly productive life that we can enjoy to the fullest potential. So at a high level, the question which excites us is, can we use these insights to make 70 the new 40? Because 40 is when we start seeing a sustained deterioration in our health. And
you're talking about yourself, not me, right?
No, of course, even at 120, you look like 40s, right? So
exactly. So Sumit, before we go a little deeper into this question of DNA, I'm hearing a lot of these words nowadays: DNA, microbiome, and 100 other things, and gut bacteria, saliva bacteria, and especially in the post-pandemic world. And I believe it is post-pandemic world because we already have vaccine. I'm an optimistic person. Can you define what is really a DNA? And we have 7.8 billion of us. How does that differentiate between one person to other person?
Absolutely. And, the pandemic is an incredible context. I mean, as an entrepreneur, you have to be fundamentally optimistic about what we do. And you have to be excited about the possibilities of technology and pushing the frontiers and working together with the right team to make that real for every person on the planet. And so what the pandemic has done on the positive side is, in the past, genomics and other omics like microbiome and others were, mainstream in the scientific community. And what has happened with the pandemic is that it has captured popular imagination. So you can have a very informed conversation with the average person around what's happening in the world of genomics and how that's impacting us, because COVID-19 has made that real. I mean, if you look at what's happening with the vaccine, an accelerated development, which in previous years would have been unheard of. I mean, to have a vaccine within 12 months is absolutely fantastic scientific achievement. So the way to think about the DNA is, think of it as the book of life, right? So think of it as the instruction manual, which has come with each one of us. And the good thing is we have now learned how to write that book of life, right? So we've learned how to convert the biological piece of information, which is in our cells, into machine readable information. And to give you context, that DNA is typically about 2 meters long, and it's coiled into something which is about 0.6 micron across.
2 meters. Wait. I'm a little confused here. I'm not even 2 meters tall. So where the hell this 2 meter comes?
Well, that's the beauty of what nature has done in terms of packing all that information in every cell of our body. And when you convert that into machine readable information, if you were to...
So you can have machines to read that 2 meter long, something encoded in me and passed on for thousands of, or I don't know how many generations? Really?
Absolutely. Absolutely. And if you think about the sequence, so that act of converting that is called sequencing. And the sequencing, um, if you were to write it in font size 3, large folder books, a typical person's DNA comprises of 3 billion base pairs. So imagine 3 billion letters, words written across the book of life, and that is the code that we are looking to interpret. So we have phenomenal advancements in the ability to sequence the DNA. And to give you context, as you would have heard, the first human DNA, which was part of the Human Genome Project, costed $2.7 billion to sequence. Now we can do
Wow.
it for a few $100 in just over 15 years. That is a remarkable achievement, right? It, and so you have a technology which is becoming mainstream and affordable. The second thing which we need is to interpret that DNA is, as we have this vast amount of information, is the ability to be able to process that and find patterns when you compare it against other similar pieces of information and other DNAs. And that's where the whole world of cloud compute, AI, machine learning has come into fore.
Let's not go there, Sumit. I have a lot of questions from you because I'm really confused, and I believe I'm a very smart guy. But when I talk to you, I feel like I have no clue. So let's go back. We have 7.8 billion people, roughly, on Earth. We are going to add 3 billion more in next 20 to 30 years. So Earth population maybe 10 plus billion in next 20, 25 years. You are saying all of us have these 2 billion characters of story, and which is written even before we are born, or what? That's one question. Second observation I have from what I heard from you is how different it is from you and me to my friend Joe and my friend Sean. And another question around that is not a question, just an observation, because before I talk to you, I read a little bit about it. As a common person, I'm finding it, if you and me are same, then same Panadol should work for us. If you and me are different, same Panadol shouldn't work for us. So how this whole process of health or business of health is working today?
Absolutely. So first of all, it's 3.2 billion base pairs. Now the beauty of the DNA is it's only made of 4 letters, right? So it's A, T, C, and G. And the other beauty of the DNA, I mean, as you would have seen in the popular, is the double helix.
So it's like music notes. Nice. So if you can play guitar, you can understand DNA. Is that right?
It is the language of DNA. And A and T, the other thing is A always binds with T, and C always binds with G, which means if you read one side of the DNA, you're able to read that information. Wow. The second thing is, of that 3.2 billion, you're absolutely correct. The difference between typical human beings is somewhere between 1 to 3 million points. So it doesn't seem like a lot when you look at the totality, but a different letter in different places can mean a variety of things, whether it is from the genetic heritage, or it is from a risk of a disease, or is the color of your eyes or hair, or etc. Now, how we inherit it is, so we have about, this book of life is the 3.2 billion letters are organized across, or words are organized across over 20,000 genes. And these are across the 23 pairs of chromosomes, which one side...
Oh, hang on. We were talking about A, D, C, and G. Now you have those, how many pairs of chromosomes?
So 23 pairs of chromosomes, which we inherit from our mother and our father. So think of it as the history being passed on to us. And so one side is we inherit from our mother, and one side we inherit from our father. And that's why when you look at the traits and the combinations, those things have predictive power, which can enable us. I mean, what really excites is if you're able to understand what is written. Now we know how to write. If you're able to understand what is written in there, because we only understand a bit of that language, it means that we may be able to use that information to enable each person to live a productive as well as a healthy life to their full potential. And I think that is really exciting.
That is really interesting. So, Sumit, I'm constantly hearing that because of the data we have today, we can even go to a point where we can not only reverse age, reverse your biological age, or how you feel that age, because I find it difficult that, oh, I'm 70, but I feel 40. I don't know what that really means. But personally, I feel I today in better shape, at least in my mind, than I used to be even 20, 30 years ago.
Yeah.
So, but I haven't done any DNA level study, the food I am eating, the pills I am taking. Are you saying that we are getting into the era where everything is going to be personalized just to me based on my DNA, or what?
See, if you think about it, we are digitizing humans, right? And genomics is one aspect of that digitization. The other aspect, which you talked about, like microbiome and other omics, are giving me a better sense of who the individual is. And each one of them, what we are all working towards is figuring out what that impact is for each one of us, right? As in, now we are all unique, but within that uniqueness, we also have certain patterns. And I think that is what is really exciting, is to personalize that life experience to you. And going back to your point, some drugs may suit you, but may not suit someone else. And the ability to be able to look at the way the drugs are metabolized.
I want to interrupt you here.
Yes.
This is very important topic, and I wanted to go a little deeper. Some drugs suits me and won't suit me. How do we define that? Because I'm hearing it for last 10 years, but I still go to the doctor and he still give me the same pills as he's giving to anyone, whether he's a Caucasian or Indian or any other origin. Not just that, I'm a vegetarian, my friends eat meat. I'm pretty sure all of these things has an impact. So why same drug, and how same drug work?
So these are, look, medical science advances based on empirical data and proof that supports the hypothesis, right? What we have learned is that there are certain genes which impact how we metabolize certain drugs. And again, it's a growing field. So that field is called pharmacogenomics, which means that we are able to then look at which drug is going to be appropriate, and we can personalize a lot of that to the individual. Of course, over time, as we get to do further research and are able to understand that even more, what we will be able to do is personalize for the entire spectrum on what drug is likely to work or not work. Uh, I could show to you that based on my genetic code, there are certain drugs which are suitable for me, certain drugs which are not appropriate for me, and certain drugs where I may have to change the dosage for it to be more effective, or reach to be effective at the level that it's expected to. So absolutely, I mean, that's one of the, and just imagine if you're going to a doctor and your doctor is about to prescribe your drug, and in real time the doctor says, let me check, Sanjeev, which one is the most suitable drug for you. It's such a positive
He's my
experience.
doctor. He's my doctor then. I'm not going to any other doctor after that.
Exactly. And so you cut down adverse drug reactions and the negative, and the associated cost, whether it's financial or emotional, for yourself or your family. And I think, look, that's the fascinating thing about it. It's about positive things that we can do with the technology and the insights that we generate.
So let's talk a little bit more about that. I am a fan of numbers. I'm a fan of data. Living in Silicon Valley, we talk about data, and data is the new oil. I had a great conversation with Mohit Aaron yesterday, from co-founder of Cohesity, and he's really, really into data. We all understand with data, we are able to not only solve problems, we will be able to create even multiple opportunities for all our audience and engineers of the future. So people like you, there are very few companies who have assimilated this data set. You have almost, I'm not sure the numbers, maybe you cannot disclose it, but you have substantial number of Asian population DNA data today. And that is very unique because if you look at the total world population, I can guesstimate at least 1.7 billion, close to Asian, if I'm not mistaken. Am I right?
So South Asian, yes.
South Asian.
The South Asian is in that range, yes.
So let's talk about, so 1.7 billion, that is almost 20-30% of the total world population today. So that represents a substantial data set. Now, if we combine it with the entire data set of 7.8 billion, now we have this magic of data set, which we apply to clinical studies. And we don't need to even do clinical trial, real clinical trial. We can run all these simulation on computers on the 7 billion or 7.8 billion data set and find what is working, what is not working. Am I right?
The answer to that is, that is one of the exciting possibilities which is already being realized. Right. So, so to answer that, absolutely. So, the fundamental problem that we started by solving is one of genetic data bias. Now, we talked about the possibilities of what the future will look like, but if I come in and say, Sanjiv, I'm going to personalize your entire life experience. But hey, by the way, I do not know enough about you or what people like you should look like. But I'm going to compare you with someone who I know is very different from a genetic makeup perspective. I will never be able to personalize that life experience, and that has been the challenge that has been in the industry, which is the data bias, where 80% of all data is from people of European ancestry. I mean, if you look at the Indian subcontinent, that's about 0.2% or less than 2% of the genomic data sets which exist. So to be able to curate, to build that with the right ethical consents, the informed consents, with the right associated phenotypic records, because ultimately we are looking at not just sequencing but correlating that, is been a significant and rewarding problem for us to solve and move forward on. But then let's get into the use case, right? And the use case is around.
Sumit, I lost you. I can't hear you.
Are you able to hear me now?
Yes.
Okay. So I was just talking about, the use cases. And right now, when you think about the COVID vaccine, because it's top of your mind, typical time frame for developing such a drug is between 10 to 15 years. Okay. The success rate is about 8%. So, over 90% of whatever enters clinical trial will fail. And when you look at the cost is on an average about $2 billion. And the industry spends about, roughly $200 billion every year in terms of R&D. So it's a big spend which is coming across industry and, NIH funded academia and other aspects of that in R&D. Now, if I were to tell you that adding genetic and biomarkers triples my success rate, right? So instead of 8%, I have 26% success rate. It fundamentally cuts down the cost of development to maybe a third or a fourth of what the cost of or the time to develop that is. And finally, from a cost perspective, rather than $2 billion, it halves the cost, which is roughly 50% of that. That is a fundamental transformation that we're seeing. And that comes back to the genetic code, which we combine with the phenotypic code and the cohorts to be able to analyze that. The way to think about it is it's a transformation that we last saw was in the 90s with the internet, where technology came to bear, it came into play, and it was started. There were use cases which then started disrupting various industries, and the entire business model had to evolve. That's exactly what we are seeing in healthcare right now, where multiple industries, whether it's pharmaceuticals, whether it's insurance, whether it's consumer care, where the entire personalization experience will come into play, are being impacted by the technology and by use cases and people learning how to use this technology and the data to move that forward. But the challenge is around that genomic data bias, and that's why, look, while we have insight into the 1.7 billion, which is not a trivial number. I think the impact we have is on the global, just as a use case is on global therapeutics development, because the novel insights that we find are useful to build better drugs and medicine which are applicable to a global population. And I can get into more examples of that as well on some of the things that if you're interested to know more about it.
So Sumit, I love to talk to you, and you and me can talk for hours because health is one of my interest area. And I can clearly see, especially in the last 4 years, just because I changed a lot of things around me, I feel very different even. In fact, you and me met 2 years ago in Venice, and that's the first time when we met and talk about what you're doing. And it fascinates me, and I study the area you are working in. So let's talk a little bit more, and it is maybe a little controversial topic today. When we talk about DNA, we are talking about even gene mutation today. We are talking about CRISPR. We are talking about cloning. So the problem and the concern I have it is how far are we taking? And one is it really solving some problem which we have, or is it creating a new problem which we don't have? That's one. Second is, how do you see the world evolving going forward? Because more and more data I see, it seems like we are ignoring several aspects of it. So even if I look at the clinical trial data, maybe you cannot say it, but I can say it as a consumer. The test clinical trial results are on a very small sample. We are talking about less than 1,000, some cases less than 10,000 people. There is hardly any test done beyond 10,000. Correct me if I'm wrong. Real human beings. Am I right?
Sorry, I was waiting for you to close.
Yeah.
So it depends on what kind of trial that is and what that would mean, because each phases are very well structured in terms of what they're looking to prove from efficacy, safety perspective.
Right. So the question I have, Sumit, is let's talk about gene mutation, because you are an expert of DNA and you have built a very successful company. You have data set of some phenomenal, so many people and so much data. I'm sure a lot of pharma companies must be chasing you today. What do you think about gene mutation? Is it a real problem? And if it is a real problem, how are we solving it? And are we making it worse by different drugs or different vaccines?
So let's first address the point, right? Which is on the let's take a use case on why it impacts. So if you look at oncology, as a drug class, historically it's been known that 3 out of 4 patients, the drug doesn't have effectiveness, right? On the other hand, when you add a genetic insight into it, both from a tumor perspective as well as for the individual, what that does is you can then start prescribing and personalizing the treatment. And that, I think, is every day that we spend extending somebody's life, I think is absolutely rewarding, because you cannot put a value to that moment for that particular individual. So already we are seeing massive impact. The other aspect which you're talking about is something called CRISPR, which is which won the Nobel Prizes, as you know, this year with Dr. Jennifer Doudna and her collaborator, who won the Nobel Prize for CRISPR. It's a phenomenal technique with a phenomenal promise. But what that then delves into is the question of something that you addressed, which I absolutely agree on, is the morality and the ethics around how we use technologies and all great technologies. And I think I'm very pleased to see how considered the approach has been from participants around how putting the parameters around it, asking some really deep questions about what is life saving versus what is enhancement, right? What does it mean to change the health of an individual versus changing the health of future generations? And I think those are really important ethical questions, which I think all great technologies people are considering and working on. And that is why I would always emphasize that whenever we work on this, the ethics around it, the IRB approvals to be able to pursue a certain insight or a particular scientific line of query is really important, because that institutionalizes the ethical framework around these things. So I think the question, Sanjiv, that you've asked is, look, these are great technologies, and I think it's hugely exciting. Even now, when we look at CRISPR-Cas9, for example, the DNA editing technologies, which are pretty recent, but the impact it has had in terms and the possibilities it offers is absolutely phenomenal. And which drives into, I love your T-shirt, which says "Future is now." When you think about future is now, imagine using these technologies in a way that we can fundamentally transform the life experience for every individual. We have to look at the paradigm and see how we change the paradigm. Right now, what happens? I fall sick. I have certain symptoms. I go to my doctor. I get I get a drug which may or may not work, or which will have different degrees of effectiveness, and I treat the symptom, right? Now, imagine a world where I'm able to, using the genetic information and other aspect, being able to predict what I have to manage, ward off, and use that information with my healthcare provider to be able to, in certain cases, ward off diseases before they happen, or when they do happen, to be able to personalize the treatment so that I get the most effective treatment, which is personalized to me as n equal to 1. And I think that's what these technologies are allowing us to achieve. And so that is a phenomenal promise. I mean, that's what excites me.
Sure. So Sumit, let's kind of go a little. Can you hear me, Sumit?
I can hear you now.
Sorry. So Sumit, let's go a little deep dive the drugs and how these drugs work on us, because there is even I don't really understand when I take a pill what happened in my body, how it really function, what it fixes. I let's say I have a headache and I take Tylenol. What it does really? Can you talk a little bit about that so our audience can understand the process of how we get cured?
Sure. Look, there are multiple ways that these things work, but essentially what you're trying to do is you're trying to stimulate a particular switch, if I may say, move it into an on and off position. I'm being very...
And you added one more thing. Earlier it was signature, then you talk about DNA, then you talk about chromosomes. And now there is a switch. You better decide. I cannot understand so many things. So switch means switch of the DNA or switch of something else?
Switch off the function, the function on and off of a particular thing that you're looking to achieve, right? Mm-hmm. So let me give you an example, which is a very interesting example of that. There was a group of people in Iceland that scientists found that who, irrespective of whatever they did, they never had high cholesterol, right? So they said that is a very interesting finding. So like all science, scientific programs, basically they tried to look at what was causing that, and they found that there was a particular gene called PCSK9. And in those things, I mean, in those individuals, in a very base level, if you were to think about it, that gene was inhibited, which was, in the simplest way to think about it, is that gene was switched off, right? And so the next bit that the science the scientists said, look, what if we were able to replicate the same behavior in people who are not Icelandic, but who have a similar symptom or a similar disease, and they took that on a global population, and they found that when they said, how do we do that? And that's where the pharmaceutical companies are great at, is looking at the compounds which can stimulate that behavior, right? So they were able to find the compound which was stimulated that behavior, and they said, look, when they applied it on the global population, they found that it lowered cholesterol. Now that is that compound and the modified version passing through the safety parameters and the very rigorous FDA testing and regulatory regime, then became a drug. So that's essentially the drug, which was then based on a PCSK9 inhibitor, became a drug which could help solve one problem. Now imagine. Now, which is why when you look at India, the Indian subcontinent has over 4,500 ethnicities. It's got almost 50% of the world's ethnicity, because we have roughly about 10,000 ethnicities. Now, in the curated, very structured cohort, imagine finding people who exhibit similar manifestations. An example being in the Indian subcontinent, we found certain people who never felt pain. Right, so researchers found certain people who never had pain, and they found that there was a particular gene called SCN9A, which was impacting, and that led to the next generation of pain relief medication. Now imagine being able to do that across different populations, which is called curated, draw that insight, and then apply it on a global level. which basically then means, something that you have said when we were discussing before. Can we make illness optional? Right? How can we solve for disease? Can we make illness optional? That I think is what we are what I think we're working towards, and that's what I meant by a switch on saying, look, if it's a switch on or off, and it stimulates to lead to that manifestation, that's what the drugs are doing, which is helping us get to that situation.
So, Sumit, I understand from where you are coming. So let's talk a little bit deeper on this topic of how we get cured. And I will use the example of oncology and cancer drugs. Most of these drugs goes and kill something in our body. Now, those cells may or may not be the problem, but it kills a lot of those cells for us.
Yeah.
And today we have phenomenal technology. We are working and developing more and more technologies. We are talking about artificial intelligence for ages now. We are talking about building these kind of a capsule which goes inside our body and can take care of the bad cells in our body, which are really causing cancer or some other disease. How far are we from that future where I don't need to take any pill? I have something inside me which is constantly watching, just like our body already does that. Our body is a very intelligent body. In fact, we got a cut, it knows how to fix it. So how far are we from solving those kind of problems using technology instead of taking pills? We have something inside us curing us. I don't want to call it a robot, but I don't know, it is almost like a micro robot.
I think, look, the body is an incredible system, right? And when you add the what we are discovering almost every day about how our body works and the ecosystem, like the microbiome and other things that comes into play, as an engineer, it is mind-boggling around the phenomenal secrets that it holds. So I would say that some of the aspects of what you have described. I would not be surprised that it will become more and more mainstream over the next 10 years or so, right? And a decade may seem like a long time, but a decade is not really a long time for an innovation to come into play. So when you get into the 2050s, right, when we think about our next generation, right, when the kids grow up and they look back, I'm sure they look back at us and say, you guys were totally barbaric. You had a problem, you cut things out, you did surgery, you did all these things, and just imagine, they will say, look, you should have been smarter, right? So they will have a very different paradigm, and I think that will happen within a generation of what's happening. And I think the future where, if you remember Star Trek, and you had Dr. McCoy, who once had to go to the back to the 20th or 21st century and saw a woman on a stretcher who was about to go into an operation, and his comment was, operation for this, have this pill. What is this? Is this the dark ages? I think that's the sort of reaction that we will generate. So I'm very optimistic, and what I'm really encouraged by is look at the amount of investment which has gone into this area, right? Genetics is hot at this point of time. The impact of genetics when you combine with the AI machine learning is incredible. We look at the returns that people are getting, whether they're investors or stakeholders, that is phenomenal. Whether it is financial or it is the scientific discoveries or it is emotional, all these things is the value that is being delivered is phenomenal. So I think with so many positive things happening and reinforcing positive things happening in the ecosystem, the key components are there, and when you fit that in, that's only going to accelerate to the vision that you've outlined.
Sumit, it's such a phenomenal conversation. I can continue to talk to you about health for hours and hours. And the health is something so important and so critical for humanity. We are trying to solve health problems for thousands and thousands of years, and we're still not able to understand the human body. And we talk about going to Mars and other stars. So sometimes it baffles me, where should we focus? But on the same note, we are explorers and we will continue to find new frontiers. So I want to thank you on the behalf of all of our audience and IIT community, uh, because people like you are pushing the envelope. People like you, I call them trailblazers, and the world call you trailblazers. I'm so glad that you took a problem which is not an easy problem to solve. And the problem you're trying to solve is the future problem. So uh, before I close this, our show, is there any message you have for our audience?
Look, first of all, of course, thank you for those kind words. And look, I just happen to be the one having a conversation. The real credit goes to the team, and I'm very fortunate to have a phenomenal team which understands the topic in depth, and a phenomenal set of collaborators and supporters who are there and who are supportive of the vision. Right. I think, look, it's the IIT ethos. When we trained in India, what we have, the kind of peers that we grew up with, gave us the foundation for the future, and that is the skill and the experience that we're applying every day, right? And what is really encouraging is that we have people around us who are smarter than us and who are better than us, who are motivated to come alongside, work with us to solve that problem, and are looking at different aspects of different problems, whether it's going to Mars, whether it's solving the genomic problem, whether it's solving other aspects of how do we make things happen. So thank you for the opportunity to engage with the team, and let's work on the mission of making 70 the new 40.
I'm all in for that, and hopefully I'll go to 20. Not that I wanted to go back to 20, but with the same wisdom I have today, and I want to go back. Sumit, I forgot to ask one question, most important question. What was your hostel?
Oh, I was Aravali.
Aravali. So go Aravali.
Arakantu hai hai.
Arakantu hai hai. Cool, man. Thank you. Sumit, thank you very much for joining us today and supporting our community globally and really inspiring young budding alumni from IIT as well as all the people around the globe. You are really pushing the envelope. I saw your interview on TEDx where Mr. Shah Rukh Khan even introduced you. So I'm so glad and so proud of you, what the work you are doing, but especially your contribution to global community. And you have taken really a difficult problem. It's so important for humanity to work on these complex problems. It's not just about putting man on the Mars. It's about solving the problem of the man who is already on this earth. Thank you very, very much for that again. I'm Sanjiv Goyal, conference chair of IIT2020.org, Pan IIT USA's mega virtual event. Please register. Our event is free and it is open to all. Please join us on December 4th and 5th. We have phenomenal speakers such as Sumit and several other people. Please register at IIT2020.org.